So this is lesson 3, solving equations with adding and subtracting. So what we need to know today is that an equation is a mathematical statement that has two expressions that are equal. And a solution of an equation is a value of any variable that makes the equation true. We have to remember when we're doing these in equations, I like to think of them as a balanced scale. So down here in the bottom left, and you always have to keep it balanced and perform the same operations on both sides. So if you had 10 stones on each side of that scale and you took 3 off the left side, you'd also have to take 3 off of the right side. So here we go. We're going to start solving equations using addition at first here. So if you see, I have an equation, x minus 10 equals 4. Since 10 is being subtracted from x, I want to add 10 to both sides. So let me grab my pen tool, and I'm going to add 10 to both sides of my equation. Remember, we have to do the same thing to both sides. Well, negative 10 plus 10, that makes 0. So all I have here is x, and 4 plus 10 equals 14. So that equation means that x equals 14. So if I go and I put 14 back in for x to check, 14 minus 10 equals 4. 14 minus 10 is 4. That equals 4. Check. Let's try number 2 here. So 2/5 equals m minus 1/5. So again, since 1/5 is being subtracted from m, I'm going to add 1/5 to both sides to try to undo this subtraction. So I add 1/5 to this side, and I add 1/5 to this side. Remember, when we add fractions, all we do is add the numerators, the top part, the denominator stays the same. So 2 plus 1 is 3, the denominator is still 5. And on this side, negative 1/5 plus 1/5 is 0, so it's leaving me with just m. So to check this, I would say 2/5 equals m. I'm sorry, not m. I would plug in the 3/5. Let's erase that. I plug in 3/5 minus 1/5. And yes, 2/5 does equal 3/5 minus 1/5. Check. So that's how we solve equations using addition. So the next logical progression here is to solve equations using subtraction. So looking here at number 1, I have x plus 7 equals 9. First, what I'm going to do is I notice there's a plus 7, so I'm going to take and subtract 7 from both sides. Whatever I do to one side of my equation, I have to do to the other. So since 7 is being added to x, we subtract s from both sides to undo the addition. So the x plus 7 minus 7 is 0, leaving me with just x. And over here I have 9 minus 7, which is 2. So let me go ahead and check that. I will put 2 in for x in the original equation. So now I have 2 plus 7 equals 9. And that is true. 9 does equal 9. Alright, let's try this one below, number 2 here. It says 0.7 equals r plus 0.4. Alright, so again, I have addition going on. So to undo addition, I'm going to need to subtract 0.4 from both sides. So let me do that over here. Subtract 0.4. And on this side, I also have to subtract 0.4. So 0.7 minus 0.4 leaves me with 0.3. And 0.4 minus 0.4 leaves me with just r. So let's check this. Let me put 0.3 in for r. So 0.7 equals 0.3 plus 0.4. And yes, 0.7 equals 0.7. And I've found my solutions to these equations using subtraction. We also have a method that we call adding the opposite when we solve equations. Now this will always work, and once you start working with more and more of these, you'll see exactly what I mean by this will always work. Let's take a look at this first example where it says negative 8 plus p equals 2. What we mean by add the opposite is you look at that number and we add whatever has the opposite sign. So in this case it says negative 8, so I want to add a positive 8. So in other words, I'm going plus 8 to both sides, plus 8. So negative 8 plus 8 is 0, leaving me with just p. And 2 plus 8 is 10. So let's see if this worked. It's by checking. I will take my 10 and plug it in for p. So negative 8 plus 10 equals 2. And negative 8 plus 10 is the same thing as 10 minus 8. And so 10 minus 8 is 2. So 2 equals 2. And that checks. So same process happens in this next one here. Negative 15 plus w. The opposite of negative 15, really what we're using is what's called the additive inverse. We want to find the number that can be added to negative 15 to make the result be 0. And it's always just the same number with the opposite sign. So in this case I'm going to add a positive 15. So again, plus 15. Actually, this doesn't say equals anything, so let's make this equal 3. So plus 15 to both sides. And I have now negative 15 and positive 15 is 0. So I have just w on this side. And 15 plus 3, or 3 plus 15, is 18. So let's check. So I have negative 15 plus 18 equals 3. And again, this is the same thing as saying 18 minus 15. And so that is 3 equals 3. And once again, this checks. Alright, so let's take and apply everything that we've learned so far to a real-world type example. In this case, the example reads, a person's maximum heart rate is the highest rate in beats per minute that the person's heart should reach. One method to estimate the maximum heart rate states that your age added to your maximum heart rate is 220. Using that same method, let's write and solve an equation to find the maximum heart rate of a 15-year-old. Okay, so we want to try to come up with, we want to piece together all the information from this word problem. First, we need to try and make an equation that's going to make sense, that will kind of always work with what we're trying to do here. So there's some keywords. Down here I have the word age. Let's highlight these. I have the word age. We have the word added to. We have the word maximum heart rate. We have is, and we have 220. So we have all of those 5 pieces. So let's take and say we're going to call the age just A. Added to simply means plus. The maximum heart rate, let's call that R, R for rate. Is, whenever we see is, we mean equals. And 220 is just 220. So you might be asking, why did I use A and R? I simply used A and R, A for age and R for rate. Those letters, the choice of letters here don't really mean anything. I just used them to try and make it so I can remember what it is I'm using them for. So now let's look back at this question, and it says using this method, write and solve an equation to find the maximum heart rate of a 15-year-old. So what do I know? I know that the person is supposed to be 15 years old. So 15 years old is an age. So I'm going to replace the age with 15. So here I have 15 plus R equals 220. Now this is an equation that we can solve. We're going to solve this using the subtraction method. Since I have 15 on the left side, I need to subtract 15 from this side. And whatever I do to one side, remember it's like a scale, I have to do to the other. That leaves me with just R. 15 minus 15 equals 0. That leaves me with just R equals, and 220 minus 15 over here, that equals 205. So can I check this? Sure, I can check this. Let me erase something here. Let me erase this. Leave the answer. So if R is 205, I had, remember it was A plus R equals 220. And if A was 15 plus R is 205, does that equal 220? Well, 220 equals 220, and once again, this checks. So now it's time to check our understanding. Once again, please do this on a separate sheet of paper so that you can turn it in tomorrow when you come to class before we work on our problem sets in class. There are two pieces of directions here, so make sure you read them. It's write an equation to represent the following relationships and also solve that equation. So there's three of them here. You're going to take these number sentences and you are going to write them into equations, and then you're going to solve all three equations. If you are having a problem trying to put these into an equation, you are going to want to look back in your notes from lesson 1, or go back and even watch the video from lesson 1 and see how we transferred words into actual expressions. It'll be the same thing to make an equation. All right, good luck, have fun, and I will see you all next class.